Well, again, I'm Patrick Byers, Horticulture Field Specialist with University of Missouri Extension. I'm based in Webster County in Southwest Missouri, and I've spent the better part of my career focused on specialty crops, including fruit crops. And I'm very excited to be with you here today to be talking about strawberry production. This presentation will be focused on commercial strawberry production. If you're a home gardener, stay with us. You'll find lots of useful information that relates to growing strawberries in the home garden. So our presentation tonight will be broken into these parts. First, we'll have some introductory material. Then we'll talk about the two primary ways that strawberries are grown in the Midwest, and those are the Perennial Matted Row system and the Annual Plasticulture system. We'll talk a bit about growing strawberries in high tunnels. This is a relatively recent development and I think offers good potential for farmers here in the Midwest. We'll talk about strawberry integrated pest management. We'll talk about harvest and post-harvest handling of strawberries, and then we'll talk about marketing strawberries. And then we'll end with some thoughts on the economics of strawberry production. So why would a farmer, or a home gardener for that matter, consider growing strawberries? Well, first of all, of course, it's a well-known and desirable fruit. We have a long history of successful commercial production of strawberries here in Missouri. And in fact, if we were to step back 75 to 100 years, we would find a much larger scale strawberry industry in Missouri, and especially in Southwest Missouri. It's a valuable crop with good profit potential. It's also a crop that returns that potential in a short period of time. Generally, the return on investment, the payback period, is within a year of planting the strawberries. They're relatively easy to grow. There are a number of marketing venues that are available for strawberry farmers. And there's also good potential for strawberries to be a sole ingredient or a part of a value-added product, which again can further enhance the profit potential of strawberries on the farm. Of course, there is the rest of the story. As is the case with all specialty crops, there is an economic risk to growing strawberries. Things can happen, things that can adversely affect the profit potential of strawberries on the farm. The plantings are short-lived. Even with perennial matted row plantings, typically we're talking about a 3 to 5 year productive lifespan of a planting. The crop is labor intensive. The plants are vulnerable to environmental problems, and yes, we can manage some of this particular risk, but there are still some underlying aspects relative to environmental vulnerability of growing strawberries. There are pest and disease issues to consider with strawberries, and then of course weed management is a primary consideration with strawberries. Now, anyone who's considering growing strawberries, either on a commercial scale or in the home garden, should learn some terminology. And there are some specialized terms that you'll hear me use tonight, and you'll also see these terms when you read about strawberries or visit websites related to strawberries. So let's go through some of these definitions. When we plant a strawberry, we typically consider that original plant to be the mother plant, okay? The mother plant is made up of a root system, it's made up of a crown area, and then the foliage, which eventually develops after it's been planted. These mother plants produce runners. Runners are a specialized above ground stem, and at intervals on the length of the runner, there are what are called daughter plants. Sometimes there's as many as 2 or 3 daughter plants per runner, and a single mother plant can produce a number of runners. Now, in botanical terms, these runners are called stolons. Strawberries also will divide, the original crown will divide and form what are called branch crowns. And if we look at this upper picture, and if we look closely, we can actually see 4 to 5 branch crowns in this established strawberry plant. The original plant was a single crown, but over time, additional crowns will form around the original mother plant. Let's talk about strawberry foliage. Strawberries have a compound leaf, and there are typically 3 leaflets to each leaf. And in botanical terms, this is called a trifoliate leaf. And the reason I mention this is that when we talk about foliar testing of strawberries, I'll talk about collecting the most recently developed, fully expanded trifoliate leaf. And that's what we're talking about. We also talk about the leaf petiole, and that is the stem that connects the trifoliate leaf to the crown of the plant. Okay, you can think of that as the leaf stem. This is important because in some cases we actually collect leaf petioles to do nutrient analysis. Now let's take a look at strawberry blossoms and developing fruit. The upper picture is a close-up of a strawberry blossom, and these are the primary parts that we're interested in as strawberry farmers. First of all, of course, the petals around the strawberry flower. There's usually 5 to 8 petals on a strawberry flower. Within the center of the flower, we have both the male and the female reproductive parts. The male reproductive parts are called the stamens, and the stamens produce pollen. The center of the strawberry contains a number of pistils. And if you look closely at a strawberry blossom, you'll notice the structures, they're yellow or golden, and they are on the surface of the receptacle. Okay, the receptacle is actually a portion of the female part of the flower, but it doesn't actually contain the reproductive structures. Those are contained within the pistil. And each receptacle will have quite a large number of pistils present on it. And in order for pollination and fruit development to take place, the pollen must move from the stamen to the pistil. Now, if we look a little closer at the early development of strawberry fruit, we can see that in the lower picture. Again, we can see a blossom in the center. In the upper left, we see a blossom that has been pollinated and lost its petals. And then in the lower right, we see a developing berry. Now, again, pollination is necessary for the development of the berry. And as we'll see here in a moment, each one of those pistils will develop into an individual seed. And there must be sufficient pollination, a sufficient number of pistils that are pollinated, and a sufficient number of seeds developing to give us a uniform large size in berries. We also sometimes hear the terms primary, secondary, and tertiary when we talk about strawberries. And this reflects the blossom and fruit order on a cluster of berries. And a cluster of berries, a cluster of blossoms, and eventually a cluster of berries is called a truss. And within the truss, we have, first of all, the primary blossom. This is the blossom that develops first. You can see it there at the very center. Not as noticeable as I'd hoped in this picture, but that is the first blossom within that truss to open. And typically it has the potential to produce the earliest ripening berry within that truss. And in many cases with many cultivars, it's the largest berry within the truss. So primary berries are quite important from the standpoint of overall productivity. The second group of berries that develop are called the secondaries. And within a truss, there's typically 2 secondaries. And you can see those noted here in the picture as well. And then we frequently have what are called tertiaries. The tertiaries develop below the secondaries, and you can see these here represented as blossoms. Now again, notice the primary will be the first berry to ripen. The secondaries will be the second flush of fruit to ripen on that plant. And then the tertiaries will be the third and sometimes the final berries to ripen. Now with many cultivars, we have a decreasing rank of size from the primary to the tertiary. Other cultivars, the size of the berries is quite uniform across primaries, secondaries, and tertiaries. And then if we take a close look at ripe berries, first of all, the green area at the base of the blossoms is called the calyx, and there's usually a stem attached to the calyx if the berries have been properly harvested. Looking more closely at the fruit itself, each of those individual seeds is called an achene. Okay, and as I mentioned before, we have to have a sufficient number of achenes developing on the berry to give us a uniform large berry. If for some reason we don't have complete pollination, or perhaps we have frost damage that damages the developing achenes, we can have misshapen, distorted berries. And then the receptacle tissue, the part of the berry that we actually enjoy, the part that is sweet, juicy, and delicious, is the receptacle tissue. Again, the overall experience of eating a strawberry is a combination of eating the achenes, which give it a bit of crunchiness, and the deliciousness of the receptacle tissue. Now we should talk about different types of strawberries as well. And the strawberry is a very interesting plant, and there are still some aspects of the physiology of strawberries that are not completely understood, but we do know that there are 2 broad types of strawberries that are grown commercially and also in home gardens. And these are the June-bearing strawberry, sometimes it's called the spring-bearing strawberry. With this type of strawberry, the flower buds actually initiate in the crowns in response to the length of the day. The day has to reach a critical length of time or a shorter length of time. And again, that critical length is somewhere around 14 hours for flower buds to develop. And with June-bearing strawberries, this typically happens in the fall, usually sometime in September and then on into the fall, or it happens in the spring as the strawberries begin to break dormancy before the days become too long. The June-bearing strawberry is the backbone of matted row perennial production. They also, June-bearing strawberries are also used in plasticulture as well. Again, this type of strawberry is the most commonly grown type of strawberry in the Midwest, both in field production and also in production in high tunnels. Another type of strawberry is the day neutral or the everbearing strawberry. With this type of strawberry, flower buds will form throughout the season. They're not formed in response to day length. We also have forming what are called branch crowns, as we defined earlier with this type of strawberry. Now, there is an important caveat relative to day neutral strawberry production in the Midwest. Whenever we have temperatures above 86 degrees Fahrenheit, we actually see an inhibition of flower bud development. So one of the attractive aspects of day neutral strawberries is that they will continue to produce blossoms and fruit throughout the growing season. Again, as long as temperatures are not warm enough to inhibit the mechanism that forms flower buds. Day neutral strawberries have not been grown to the extent that June-bearing strawberries have to the Midwest, but there are some places where day neutral strawberries could be a profit center on a specialty crop farm. We should also talk about planting stock. There's two basic types of ways that you can establish a strawberry planting. And one way is to work with dormant plants, and those are called bare root plants, and we can see those in that lower picture there. These are typically dug from a strawberry nursery sometime during the winter, and then they're held in a dormant state, shipped to a farmer, and then they're planted in the spring. The other type of nursery stock are what are called plug plants. And plug plants are typically actively growing plants. They're usually developed from what are called runner tips. These are those daughter plants that we described earlier. And the runner tips, the daughter plants are collected, they're rooted, and then the rooted plug plants are planted, typically in the fall. With plug plants, this is the way that we frequently will establish annual strawberry plantings. There are other types of nursery stock. There are what are called bare root growing plants that are sometimes available, but in general in the Midwest, most of our plantings are established with either bare root plants or with plug plants. Now, very important to source nursery plants of any type that are clean and disease-free. Reputable nurseries will have in place programs to test plants for the presence of diseases and particularly for the presence of virus diseases. And then if these diseases are present, they'll go to great pains to develop production fields and nursery fields that are free of these pests. This is called clean planting stock, and it's an excellent way to start off a commercial or a home strawberry planting as well. So again, do that background check. Make sure that the nursery stock that you're purchasing has been tested for diseases and viruses. And then there's two basic ways that we grow strawberries in the Midwest. One is a perennial system. We can see that in the upper picture there. The common way that we do this is called the Perennial Matted Row system. These plantings are established in the spring from dormant plants, and they typically have a productive life of 4 to 5 years. The other system are what are called annual systems. And the Annual Plasticulture system is the primary annual system used in the Midwest. With this system, actively growing plants, those plug plants we saw earlier, are planted in the fall. The planting overwinters, it produces fruit the following spring, and then it's discarded. It's truly an annual system. Okay, let's have some general thoughts now about strawberries, regardless of whether you're growing them as a perennial matted row planting or as an annual planting. A good strawberry site has full sun. Typically, elevated sites are the better sites. Elevated sites have less risk from the standpoint of late spring frost. Consider the previous uses of the site. Strawberries should not be planted after strawberries, and strawberries should not be planted after solanaceous crops like tomatoes, potatoes, eggplants, or peppers. It's not a good idea to plant strawberries after bramble crops like raspberries or blackberries. All of these crops, bramble crops, solanaceous crops, or strawberries, share common soil-borne diseases. And so it's a good practice to allow for a rotation, a period of time between planting strawberries following these crops. And typically that rotation should be 4 to 5 years. Strawberry planting should be close to a source of water. The soil should be well drained and slightly acidic and moderately fertile. Obviously, we need a soil test to give us a clear understanding of the chemistry of the soil. It's also helpful to test the soil for harmful nematodes and to think about how the strawberry crop is going to be marketed. Are we going to market the crop on farm? If that's the case, then we need to have a sufficient resident population to support the size farm that we're considering, or perhaps the farm is located near an attraction that brings people to the area. If we're marketing off farm, let's consider the distance from the farm to the market, be it a farmer's market, a pickup point for a CSA, or perhaps even a larger scale market to an institution, a school, or a hospital. Preparing a strawberry site should take place the year before planting. Okay, typically, the first step is to test the soil. Secondly, of course, is to prepare the site from the aspects of clearing away existing vegetation or other cover. Apply soil amendments as indicated by the soil test, eliminate perennial weeds, and then determine what the planting system is going to be. Will this be a perennial matted row system, or will this be an annual plasticulture system? Okay, the next series of slides is focused on the perennial matted row system. This is the traditional way the strawberries were grown in Missouri. It's still a viable system for the standpoint of strawberry production, and as we'll see here in a moment, offers several advantages. So why consider perennial matted row? Well, first of all, the initial cost is less than establishing a annual plasticulture system. There are fewer plants initially, and dormant plants tend to be less expensive than plug plants. Yes, there is some risk, but less risk than with annual plasticulture. And a good part of the aspect of the reduced risk relates to the fact that we have more plants present in the planting. And even if we, for example, do lose a portion of the crop to a spring frost, this can be offset by the fact that we have more plants and more flower trusses developing within that planting. And with this system, of course, it's a perennial system. You don't have to plant it every production cycle. And a bed should last for 3 to 5 picking seasons. There are a large number of cultivars that are adapted to the perennial matted row system in Missouri. These are the standard cultivars. There are many others that could be considered. For the early season, this includes Early Glow, Annapolis, and AC Windy. Mid-season cultivars include Honey Eye, All-Star, Red Chief, and Guardian. Late-season cultivars include Late Glow and Winona. Typically, a given cultivar will produce berries for a 2 to 3 week picking season. Preparing a site for a perennial matted row, as we mentioned earlier, the first step is to conduct a soil test and modify the soil if needed. Critically important with perennial matted row to control weeds. We don't have the benefit of plastic mulch with perennial matted row, and so weed control frequently comes down to good pre-plant site preparation, and then the use of herbicides and the use of hand labor and tillage to manage weeds. Cover crops and organic amendments are very helpful. If the soil test indicates a soil organic matter content level below 5%, then supplement that with cover crops and organic amendments. Pre-plant fertilizer application is very helpful, and this is a standard practice. About 30 pounds of nitrogen, 60 pounds of phosphorus, and 60 pounds of potassium. These can be applied in the form of organic fertilizers or in the form of conventional fertilizers. The site should then be worked, and then strongly consider using raised beds. And with perennial matted row strawberries, the beds are typically spaced 42 to 52 inches apart and are typically 6 to 8 inches high. Now, we mentioned earlier that irrigation or the availability of water is critical, and primarily we're talking about irrigation here. Now, when the beds are created, then that's the time to install the irrigation. And in many cases, the irrigation line can be installed at the same time that the plants are planted. In other cases, the bed will be created and the irrigation line laid at that point, and then the strawberries will then be planted back into the bed after that takes place. Typically, we're talking about 8 mil tube. It's a type of irrigation that has a shorter lifespan, but long enough for again, the 3 to 5 production cycles of a perennial matted row planting. The emitters should be spaced 8 to 12 inches apart on the 8 mil tube. Generally, we allow 1 to 2 irrigation lines per bed, and typically these types of irrigation lines will deliver about 0.4 gallons per minute or 24 gallons per hour per 100 feet. This is pretty standard to supply enough water for for the perennial matted row strawberry planting. When you lay the drip tape, it should be laid with the orifices facing upward. This helps reduce problems with the movement of soil into the irrigation line. It can be buried 1 to 2 inches deep. If you bury it, of course, it's not as important whether or not the orifices are facing upwards or downwards. And then once the lines are in place, tie them off at the ends until they're connected to the header line at the ends of the rows. The perennial matted row plantings are typically planted in April or May using dormant crowns. The rows 42 to 52 inches apart, and generally a single row of plants is planted per row, and the plants are spaced 12 to 24 inches apart. Now, the spacing between plants depends to some extent on when you're planting. Probably the best month to plant strawberries is in April, and if you're planting in April, there's plenty of time for the plants to become established and to develop a sufficient quantity of runners and daughter plants to fill the row in. If you're delayed in planting till, say, late May, then it's important to plant the strawberries more closely together. In the case of early planting, you can space them further apart. In the case of late planting, you can space them more closely together. And then water the plants immediately after planting to get them established and off to a good start. Let's talk about managing a new planting of matted row strawberries. Probably the most important aspect of success with matted row strawberries is weed control. And this could not be more important than it is during the year of establishment. And there's a lot of open ground around the mother plants that have been planted. In time, it will be filled in with daughter plants, and the competition of the daughter plants will help suppress weed growth. But until that happens, we have to manage germinating weeds, both annual and perennial weeds. Irrigation is important as well to keep the new stand of strawberry plants growing. Strawberry plants typically will arrive as dormant crowns with flower buds already developed within those crowns. So when they're planted, they begin to grow and they begin to form flower trusses. But it's a good management practice to remove those flower trusses, as we can see in this picture here, during the establishment year. By removing those flower trusses, we encourage good, strong growth of the mother plant, and we also encourage the formation of runners and more daughter plants, which will fill in the area between the original mother plants. Fertilization is important with the establishment year. So about 4 weeks after transplanting, apply about 30 to 60 pounds of nitrogen per acre. Again, this can be in the form of an organic fertilizer. And then again in late August to early September, an additional 30 pounds of nitrogen per acre is very helpful. This is what we don't want to see. Here's a new planting of perennial matted row strawberries. And again, we can see that in this case, the weeds are very quickly getting out of hand. Annual germinating weeds are best controlled when they're very small, whether or not we're using an organic herbicide or we're using tillage or other means of controlling weeds. But we have to manage weeds in strawberry plantings, particularly during the establishment year. And just to show you how prolific the original mother plants can be in the formation of runners and daughter plants. This is actually in the second year of a planting, but again, we see a profusion of runners and daughter plants forming, which do an excellent job of filling in the spaces between the original mother plants. Now, as we move into the fall, we don't want to let down our guard as far as fall weed control. Typically when we plant strawberries in the spring, then we face the onslaught of warm season weeds. But in the fall, we face the onslaught of cool season weeds. So don't let down your guard from the standpoint of weed control as the strawberry planting moves into the fall. Now, strawberry plants are not particularly hardy, and it's an excellent cultural practice to protect strawberry plants from damage during the winter, particularly during periods of deep cold. In the case of perennial matted row strawberries, it's a common practice to mulch the strawberries with either straw or to use row covers. In the case of straw, we need about 2.5 to 3 tons of straw per acre, and that'll give us the needed 2 to 3 inch deep mulch over the tops of the plants. If we're purchasing small bales, that's about 300 small bales per acre. If we're using row covers, we want to use heavyweight row covers, 1.0 to 1.5 ounces per square yard row covers. And regardless of whether we're using straw or row cover, we want to monitor the protection during the winter. In the case of straw, it can be blown off by winter winds. And in the case of row covers, we want to make sure that the edges have been well anchored using bags of rocks or sandbags or some other means to maintain the protection on the plants over the winter. Here's what the strawberry plants should look like in the late fall before applying the mulch. We don't want to apply mulch too early. The typical time to apply mulch is between Thanksgiving and the first week in December. We need to have several killing frosts. We need the plants to go dormant. Basically, we want to see the plants lay down, as we can see in this picture here. So this planting is ready for the application of mulch, either straw or floating row covers. And here we see the farm team spreading mulch over the strawberries. They're covering the rows first, and then they'll come back and fill in the area between the rows. Keep in mind that strawberries on raised beds will actually require more in the way of straw from the standpoint of protection, because you have a raised area of the soil that also needs to be protected with an effective mulch. So you'll require additional straw to fill the areas between the rows with raised beds. And here we see a field that has been protected with floating row cover. And again, we're using heavyweight row cover. We're placing it over the rows, and we're anchoring the edges, in this case, with rock bags. We'll talk more about floating row covers when we talk about annual plasticulture strawberries. Now, we've moved through the winter. Now we're moving into the spring. As growth begins, the mulch will be removed, whether it's straw or floating row cover. We, of course, need to think about frost management. In Missouri, strawberries flower in April, and they are certainly exposed to the risk of damage from late spring frosts. Pollination management is another important consideration, which we'll discuss here in a moment. And then we move into integrated pest management, the management of diseases and insects in the spring. We'll talk more about that a little bit later on in the presentation. And we'll discuss harvest later on in the presentation as well. So some more thoughts on cold injury. So the risk of frost damage increases as we move further along in the development of the strawberry plants. What this means, of course, is that a plant that is completely dormant is quite frost tolerant. But as development commences and continues, the more developed the blossom is, for example, the more vulnerable it is to frost damage at increasingly higher temperatures. You know, for example, a strawberry blossom that is not opened can endure temperatures into the upper 20s. But a strawberry blossom that is fully open or a developing fruit can be damaged at temperatures near 30. So again, when we assess the risk of a predicted frost, we want to look at the growth stage of the plants to get a feel for what the anticipated damage might be. Within the blossom, the pistils are damaged first, and that's unfortunate because pollination of the pistils and their development is necessary for fruit development. If we look at that lower picture, this is what's called a black-eyed flower. This flower went through a frost situation where the pistils and the receptacle tissue was damaged. The stamens and the blossoms, or the stamens and the petals, were undamaged, but unfortunately, with the damage that was suffered by the pistils and the receptacle, that flower will not develop into a fruit. Now, to help manage frost, don't uncover the planting too early in the case of matted row, but don't uncover it too late, especially if you're using row covers. Row covers can actually encourage early development. And if we start to see development within the plants, then it's time to uncover the plants. And then we have ways that we can apply, that we can manage frost through frost protection. Traditionally, this was done through the use of overhead sprinklers that sprinkled water onto the blossoms and the developing fruit. And as long as the application of water was continued, as that water freezes on the blossoms and the fruit, it releases a small amount of latent heat. And this small amount of latent heat is enough to protect the blossoms and the developing fruit from frost. And this is effective down into the mid-20s. Another way to manage frost is to replace the mulch, either the straw mulch, which is quite frankly not easy to do, or by applying the floating row covers, which is much more easy and much more practical way to manage frost. In some cases, during deep frosts, farmers have combined the use of floating row covers and overhead sprinklers to get additional protection. A few comments about pollination. As I mentioned earlier, it's very important for a strawberry blossom to be sufficiently pollinated to develop large, uniform berries. The strawberry is self-fertile, which means that pollination can take place within the blossom or within blossoms on the same plant. But research and growers' experience have demonstrated that while, yes, some pollination can take place through the movement of the blossom and the wind, it's important to have adequate insect pollination to ensure uniform large fruit. It's a common practice for strawberry farmers to bring hives into the strawberry field. Typically, the stocking rate is about 2 hives per acre, and the hives are placed at about 10% bloom, and they're left in place through the duration of flowering. Now, very important if insecticides or even other pesticides are used during this period of time, because bees are vulnerable to injury or even death from a number of different types of pesticides. So regardless of whether they're organic pesticides or conventional pesticides, always err on the side of caution if you're applying a material during flowering. And no insecticides should be used during the flowering period on strawberries. Now, we'll talk about harvest a little bit later on in the presentation. In the case of Perennial Matted Row, this is a perennial planting, and so we can keep it for more than one harvest cycle. So after harvest, it's important to go out and evaluate the condition of the bed. Again, this is done after the last harvest. The farmer will go out, take a look at the matted row. If the plants are healthy and if there's good coverage in the bed, then it's likely that planting will be profitable during the next production cycle. If the bed is thin, if there are disease issues, or if there are weeds that cannot be controlled, it may be time to discard that bed and to start production in a fresh area. If the decision is made to keep the bed, then renovation is helpful. We'll talk more about that here in a moment, but renovation is a way to renew the vigor of the bed. Weed control, critically important throughout the growth cycle. And then if the bed is to be kept, fertilization takes place during renovation, and then again in August or September, 20 to 30 pounds of nitrogen per acre at each time. So here would be an example of the decision-making process. This is a strawberry bed. This is actually moving into its third production year. And if we look in this bed, we can see, first of all, yes, we do have strawberries present, but we also have some issues. The light-colored greenish-looking weed is nutsedge. Nutsedge is extremely difficult to manage in strawberry beds, particularly organically. And if we had a sufficient stand of nutsedge, that could be a strong reason to consider discarding this planting and moving on to a new production site where the nutsedge has been eliminated. We also notice that this planting is patchy. There are areas where we don't have strawberries growing. We can see that in the foreground of the picture. Typically, a strawberry bed needs to have about 70% coverage during this post-harvest period as we move into renovation. If it has less than 70% coverage, then it's a good practice to discard that planting and start a new bed of strawberries. So renovation, we've examined the bed. We've decided that it's worth keeping this planting for another production cycle. Now we consider renovation. It takes place at the end of harvest. First step, if necessary, we can mow the foliage off, and this is typically done with string trimmers. An indication to mow the foliage off would be the presence of leaf diseases. The planting rows are then narrowed to 10 to 15 inches in width, and this is frequently done by hand with hose, or it can be done with tillers. We then place an inch of soil over the bed, fertilize the bed, again with 20 to 30 pounds of nitrogen per acre, and then we irrigate as necessary to begin the bed into the process of reestablishment and renewal. If we're willing to put some energy into renovation, it can be a very important aspect in maintaining the productivity and vigor and the profitability of a matted row planting. What would be the expected yield from a matted row planting? The experience in Missouri is that we can expect 12 to 15,000 pounds of strawberries per acre from most of the cultivars that are recommended for perennial matted row plantings in Missouri. There have been cases where farmers have experienced exceptional yields, up to 25,000 pounds per acre, but this would be exceptional. Again, probably better to consider somewhere in the neighborhood of 12 to 15,000 pounds per acre as being a typical yield from a perennial matted row strawberry planting. Now let's talk about annual plasticulture. And this is a relatively new way of growing strawberries in the Midwest. This system was developed in the southeastern US and in Florida based upon production practices in California. And it's only in the past 15 to 20 years that we've seen the adoption of annual plasticulture in the colder parts of where strawberries are grown. It's certainly a system that can be successful across Missouri. As we'll see here in a moment, there are some challenges, but we're seeing increasingly an emphasis on annual plasticulture strawberry production. So why would you consider annual plasticulture? This type of a planting typically gives an earlier and a longer season of harvest. The quality and size of the berries is enhanced with annual plasticulture, and it's also an easier system from the standpoint of harvest, both for pick your own customers and for those harvesters who are picking pre-picked berries. Again, an excellent option for pre-picked or pick your own berries. The fruit is cleaner. We'll see why here in a moment. There is less fruit disease. There's no berry to soil contact. This has implications from the standpoint of clean berries, but it also has implications from the standpoint of produce food safety. It's also a very productive system. The goal with these systems typically is to have 35 successful blossoms per plant, which equals about 1.5 pounds of berries per plant, which is the equivalent of about 26,250 pounds of production per acre. Now, will every annual plasticulture planting yield 26,250 pounds per acre? The answer is likely no, but this is still a goal that can be achieved with annual plasticulture systems here in Missouri. Okay, well, what is the rest of the story relative to annual plasticulture? It is a system that has high initial inputs. The high initial investment is about $10,000 per acre. It's a system that the success depends upon the production skill of the grower. There are many production decisions that must be made in a very timely fashion, and practices carried out in a timely fashion for annual plasticulture to succeed. Labor management is very important. As I said before, when jobs have to be done, they have to be done. You're producing a lot of berries, so obviously it's important that the grower not only be a good grower, but also a good marketer. The system certainly has the risk of crop failure. It's vulnerable to excessive rain, it's vulnerable to spring frost, it's vulnerable to spring heat waves, and it's particularly vulnerable to weather conditions that would delay planting in the fall. As we'll see here in a moment, fall planting time is critical. And if we're delayed even by as little as 2 to 3 weeks, it can result in lower productivity. And in the overall scheme of things, plasticulture production is much riskier than matted row production. A number of cultivars are adapted to annual plasticulture production in Missouri. The top 3 are the cultivars that have been most widely planted, and Chandler by far is the dominant cultivar for annual plasticulture. But we're seeing interest in moving beyond Chandler, Camarosa, and Sweet Charlie. And farmers are planting Rocco, Liz, Ruby June, Flavorfest, and Sweet Ann as June-bearing cultivars. And there's also some interest in growing day-neutral cultivars with annual plasticulture. These include San Andreas and Albion. Now, as far as preparing a site and getting ready for annual plasticulture, the first order of business is to order plug plants early. If you're ordering plug plants from a nursery that specializes in plug plants, that order should go in at least 6 months before planting. Earlier is better. It is possible to grow your own, and if that's the case, you need to get your plug tips ordered early so that you be sure of the supply of good quality Brenner tips if you're going to grow your own. Test your site from the standpoint of the soil and modify the soil if needed. Control weeds. Pre-plant fertilization. It's a common practice to apply 60 pounds of actual nitrogen per acre before raising the beds for annual plasticulture. Okay, and again, this can be put down as an organic or as a conventional fertilizer. And if the soil test indicates the need for additional nutrients, apply those as well. And then we create the raised beds. With annual plasticulture, the beds are typically about 30 inches wide, and they're about 6 to 10 inches high. Typically, it's a higher bed than we use for perennial matted row. The bed is covered with plastic mulch, plastic film mulch, and the rows are spaced 5 to 6 feet apart. Now, some additional comments on plug plants. If you're a new grower, if you're just starting out in annual plasticulture, strongly consider purchasing your plug plants rather than growing your own. This is a way to help manage risk, and you also don't have to deal with growing plug plants out at the same time. You'll be doing other things to prepare the site for for establishing and growing the strawberries. Plug plants cost somewhere in the neighborhood of 30 cents each, plus or minus. You'll need about 14,500 plants per acre. And again, that's an investment of about $4,350 per acre. Whenever possible, source these plug plants from a nursery that has a program in place to virus test and disease test their plug plants. And again, order your plants early, a minimum of 4 months. 6 months is even better. Here is an example of a farmer growing their own plug plants. And again, these are purchased as runner tips. The runner tips are sourced from nurseries that specialize in the production of runner tips. They arrive in a situation where they've been maintaining cold storage. And as soon as they arrive, the runner tips are stuck into trays of growing media. And these trays have 50 cells per flat, and each cell you place a runner tip. And then they have to be managed carefully from the standpoint of water and nutrition and disease management to get them established and up and growing vigorously. Typically, an ideal plug plant is about 4 weeks old at planting time. Again, as I said before, if you're a new grower, strongly consider ordering plug plants that are ready to plant. And again, the raised beds are 5 to 6 foot on center, 30 inches wide, 6 to 10 inches high. Higher beds are helpful because they keep the fruit cleaner, and they also help hold heat in the bed in the winter. The raised beds are covered with a 1.25 mil black embossed plastic mulch, and then a drip line, a trickle line, is placed on top of the bed, but underneath the plastic mulch. Now with this system, other than the pre-plant fertilizer, all nutrients needed by the strawberry planting are injected into the irrigation lines. Again, this is done through fertigation. And here's what a planting would look like as we're getting ready to prepare, as the planting has been prepared for a strawberry planting that will take place a little bit later on. So again, this typically takes place in July and August, where the planting is made ready for the placement of the plug plants as we move into September. Now, some more comments on the irrigation. Again, 8 mil tube put down when the plastic is laid, 8 to 12 inches between the emitter points on the 8 mil tube, 1 to 2 lines per bed, installed with the orifices facing upwards. They can be buried and they're tied off at the end until they're hooked up. And we can see here in this picture here how the ends of the line have been tied off. In this case, the strawberries have been planted. You can see the newly planted strawberry plug plants in place. We'll talk more about that here in a moment. Here's the plug plants. Again, they're planted in early September, and planting time is critical here in Missouri. Try to focus on the period of time around Labor Day for planting annual plasticulture plantings in Missouri. Typically, plantings of any scale are planted with what are called water wheel transplanters. We'll see one here in a moment. The plants are planted in double rows on the raised bed that's covered with the plastic film, and the plants within the rows are staggered. A cover crop is frequently planted between the rows. And remember that earlier picture we saw the annual ryegrass growing between the rows? It's important that the seed be broadcast and placed on the soil before planting. In fact, it's a good practice to go back. The sequence of operations, again, is to create the planting, the raised bed rows with the plastic covered raised beds, spread the seed, go back and brush the seed off of the beds into the areas between the rows. We don't want that seed moving into the soil around the newly planted plug plants, or it will become a serious weed competition for the newly established plug plants. So make sure that all the seed is brushed off the top of the raised bed before we plant the plug plants. Again, planting date is critically important. If you plant too early, let's say that you, for whatever reason, want to plant in August, remember that early planting can lead to possible excessive plant growth. In other words, too many branch crowns. We can see excessive runnering. And once we get up to the point of 8 crowns per plant, we actually see a negative impact on fruit size the following year. So we don't want to plant too early. On the other hand, we don't want to plant too late. If we plant too late, we just don't have enough time in the fall growing season to develop plants that are sufficient size to give good yield the following spring. If we plant just right, if we hit the window just right, first of all, yes, we'll have some runnering where runners have to be removed, but it'll be manageable. We'll see the ideal number of 3 to 5 branch crowns the next spring, and we'll have, again, our goal of about 35 fruit per plant. That's our target. So we don't want to plant too early. We don't want to plant too late. We want to time it just right. And again, for most farmers in Missouri, that just right period is going to be in early September. Some more thoughts on what the planting is going to look like. Again, 16 to 18 inches between the rows, and then the plants are spaced 12 to 15 inches apart within the row. And if we look at this picture here, we can see the staggered double row on the 30-inch wide raised bed. We can also see the annual ryegrass growing nicely between the rows. The annual ryegrass helps stabilize the soil between the rows. It also gives us a little bit of wind protection for the developing strawberry plants. And the following spring, when that cover crop is terminated, it gives us a surface, a carpet of plant material that we can walk on that gives us a good operating surface. It also gives us a good surface to help keep the developing berries clean. So again, an estimated 14,700 plants per acre when the plants are planted in 6-inch row spacing at 12 inches between, or 6-foot row spacing and 12 inches between the plants. And again, just some shots of planting strawberries. And again, these are shots taken from an excellent YouTube website, and it's noted there on the slide, that looks at not only the planting process, but also the use of row covers. And this video was shot at Wallett's Farm in Kansas, and it was shot by researchers at Kansas State University. The upper picture shows the water wheel transplanter. And if you look at that, you see a couple of tanks, and within the tanks are a water nutrient solution. You then see the strawberry plants, the plug plants within the trays, and then you see the crew of people. In this case, there's 2 people per row that are actually placing the plugs. The lower picture shows the actual wheel, and the wheel has metal teeth that pierce the plastic and create a hole in the soil in the raised bed. And then the plug plant is dropped into that hole. The spacing between plants is determined by the spacing between the metal teeth on the water wheel. And then the water wheel delivers a dose of the water nutrient solution as the hole is created. A very elegant way to plant large quantities of strawberries. And again, here's our annual ryegrass cover. The seeding rate is 50 pounds per acre, and it's important to brush the seed off of the row before the strawberry plug plants are planted. Management as we move into the fall. Upon planting, the plants will begin to develop runners, and it's important to remove those runners as they form. We'll talk more about that here in a moment. We'll talk more about the use of row covers, but row covers are a tool that the annual plasticulture strawberry grower has to encourage growth later in the fall if needed. And then it's very important, of course, to keep these plants well watered during the establishment and fall development period. So some thoughts on what is happening in the strawberry plant in the fall. Again, once we've planted the plug plants, we begin to see the development of runners. Anytime the day length gets to less than 10 hours and the temperatures get below 70, branch crowns will form also during the fall, particularly as we see cool temperatures and short days. And we get the development of flower buds during this period of time as well. So anytime the day length drops below, I mentioned earlier, 14 hours, 8 to 12 hours, even better, we see the development of flower buds. And this happens primarily in the fall. We get some flower bud development in the spring. And there are differences among cultivars as well as far as critical temperatures. As far as critical day length. So again, our goal is to develop a strong, healthy, large vegetative plant in the fall. And looking at this picture, which we saw earlier, if we count those branch crown numbers, this is our goal. We can see 5 branch crowns in this picture. The plant should have the diameter of a dinner plate and ideally 5 to 8 leaves. Keep in mind that small plants will not yield enough to make annual plasticulture plantings profitable. It's very important to get a strong, healthy, large plant in the fall. Now, some of the practices that will help encourage the development of those strong, healthy, large plants. First of all, runner removal. And we can see here a runner being removed from a fall planted strawberry plant. These should be done as they develop. They should be cut off, not pulled. If you pull them off, you risk damaging the crown. And runner removal should begin 3 to 4 weeks after transplanting, and it should be completed 6 weeks after transplanting. Now let's talk about floating row covers. This is a tool that is widely used in annual plasticulture strawberry production. As we saw earlier, it has a place in matted row production as well, but it's a very important part of managing annual plasticulture strawberries. These row covers are made out of spun bonded polypropylene. They're typically somewhere between 1¼ to 1½ ounces per square yard. In some cases, lighter weights are used, but frequently the row covers will be within this range as far as the heaviness or weight of the fabric. Frequently, we see 60-foot widths used. A 60-foot width will cover 10 rows of strawberries that are planted on 5½ foot row centers. Now, how do we use floating row covers? In the fall, we use floating row covers as a tool to help encourage a long enough growing period to develop, as we said, large plants that have sufficient numbers of branch crowns and sufficient flower bud development. If we have a fall that is a short fall, where we have cold temperatures coming on early, the use of row covers can actually lengthen the period of time for plants to develop. So this can be very helpful. If we're going to use them in the fall, they should be applied when weekly temperatures begin to average somewhere in the neighborhood of 50 degrees Fahrenheit, and then left on place until the plants go dormant. Floating row covers can also be used during the winter. The goals of using floating row covers in the winter is protection from sublethal temperatures and also to protect the plants from damage from desiccation. Now, using row covers effectively in the winter is a bit of an art. Okay, timing is critical, and there's still a lot of discussion as far as when they should be placed during the winter. Frequently, it's based upon a critical minimum temperature. What is that critical minimum temperature? Well, again, this is where some of the disagreement is, but it's reasonable to consider that temperature to be somewhere in the neighborhood of 15 to 20 degrees. It also depends upon the physiological state of the plants as well. Now, what about warm spells during the winter? The goal of management of strawberry plantings in the winter, whether they're perennial matted row systems or annual plasticulture systems, is to keep the plants dormant and in a state of maximum hardiness. During warm spells, particularly if the plants are under a row cover, we can see the breaking of dormancy. We begin to see plant development. And this can actually make the plants less tolerant of cold temperatures that would follow the warm spell. So if we have a period where there's a forecast for an extended warm spell, it's a good practice to take row covers off of plantings, particularly if these warm spells happen in February or early March. And then as we move into March and April, dormancy will begin to break regardless of what's going on, and cold sensitivity increases. And again, this becomes a period of time where we have to think about risk. At this point, it's in most cases, the strawberry beds are uncovered, but we want to maintain the row covers in a convenient location to place back over the plants if we do have frosts or cold periods that then come. And on the subject of frost protection, row covers can be very helpful from the standpoint of managing frost. As I mentioned earlier, the risk of a particular frost event depends upon, first of all, the predicted low temperature and also the stage of development of the strawberry blossoms. The more developed the strawberry blossoms are, the more likely they are to be damaged at warmer temperatures. Frost protection is effective early in the spring. Keep in mind that there is a risk to using row covers for frost protection. There can be damage to blossoms and foliage as we place the covers on and remove the covers, especially in windy conditions. And if we have to leave row covers in place for an extended period of time, let's say that we have 3 to 4 days of predicted frost, we can actually see some negative impacts from poor flower pollination. So again, here's an example of winter management with row covers in place. We can see the edges of the row covers anchored with bags of rocks. Frequently, bags of rocks or sandbags are used to anchor the edges of floating row covers. And again, in this case, this is a 60-foot wide piece of row cover. We can see it covering multiple rows of strawberries. This is an interesting picture. In this case, the row covers that the farmer was using were not quite long enough to cover the ends of the rows. And we can see a negative impact from the uncovered strawberries. Again, the plants on the left were uncovered. The plants on the right were protected by the row covers from midwinter cold temperatures. And we can see that the uncovered plants experienced damage. So again, row covers can be a very useful tool from the standpoint of managing strawberries during periods of sublethal temperatures. Spring management with the annual plasticulture system. Well, we remove row covers typically in late winter, typically sometime in February. We then clean up the planting. We'll see what that looks like here in a moment. Set up irrigation units and overhead sprinklers if we're going to use those overhead sprinklers for frost management. We then move into the flowering period. And again, pollination management is important with annual plasticulture as it is with perennial matted row. Frost management becomes very important during this time. Weekly nitrogen fertility management. Again, we're going to use our fertigation unit and we're going to inject fertilizers to provide the plants with needed amounts of nitrogen. Disease and insect management becomes important during this period of time. Harvest is earlier typically with annual plasticulture systems, and we can begin harvesting as early as late April. And then after harvest, the planting is then discarded. As we'll see here in a moment, the planting can be used for succession plantings of other types of plants after the annual strawberries are removed. This picture shows removal of the floating row covers in the spring. And again, it's typically going to be in February or the first week of March. Keep those row covers handy in case we need to place them back over the rows for frost protection. This would be the typical condition of strawberry plants when the row cover is removed. And we'll notice we have a number of dead and dried leaves around the plants. Leaving this plant material in place can actually foster diseases, so it's a good practice to remove these parts of the plants. And this can be done by gently raking the planting or by using a brush to remove the dried and dead leaves. Spring nitrogen fertility management. Typically, annual plasticulture planting will require a total of 120 pounds of actual nitrogen per crop. We apply about half of that in the fall before we plant the plants, and then we apply the remainder in weekly applications through our irrigation system in the spring. We begin when the first blossoms are visible. That's typically about the 1st of April. And we can also gauge the amount that we need and the rate that we apply based upon petiole tests. There are testing services in place that will allow a grower to ship strawberry petioles. The sap within the petioles will be tested for nitrogen content, and then a recommendation will come back from the lab from the standpoint of the amount of nitrogen that needs to be injected during a period of time. Typically, it's going to be somewhere in the neighborhood of 10 pounds of calcium nitrate per week per acre. And this is applied for about 8 weeks, again, starting when the first blooms are visible. Be cautious about applying too much nitrogen. This can lead to excessive vegetated growth of the plants where the plants are too tall and the fruit is then buried among the foliage. This reduces harvest efficiency and can lead to soft fruit. Now remember, our expected yields with the annual plasticulture are high, 26,250 pounds per acre. And the goal is to achieve 1.5 pounds of berries per plant. If we drop much below 1.5 pounds of berries per plant, it's questionable whether that planting will be profitable. And here's a picture, a post-harvest picture of a strawberry planting, annual plasticulture strawberry planting, where the strawberry plants have been killed out, and then a crop of squash planted back into the same raised bed. This can be an efficient way to use that raised bed. The irrigation system is already in place. There's oftentimes nutrients that remain in the bed from the strawberry crop, and the following crop can utilize those nutrients and then the bed and the irrigation system for a production cycle. Now let's talk about high tunnel strawberry production. And this is probably the most recent development from the standpoint of strawberry production in the Midwest. And it offers several advantages, as we'll see here in a moment. But basically, it's taking annual plasticulture production practices and moving them into a protective structure. Advantages, the same advantages as annual plasticulture, but we overcome some of the risks of annual plasticulture by moving the strawberry planting into a protected environment. We can also achieve an early harvest. We can advance the harvest by as much as 3 to 4 weeks. Compared to a field-grown strawberry planting by planting the same strawberries in a high tunnel. I'm not going to go into a lot of detail because it's the same strategies as far as growing annual plasticulture plantings, but within a tunnel. Very important, though, to manage high tunnel temperatures during the winter. We want to be cautious about having too warm of a temperature during the wintertime, because again, this can lead to plants that have a lower level of winter hardiness. So it's very important to keep the plants within the high tunnel in a fully dormant state, and this is done by temperature management. We can use row covers inside high tunnels during the winter, and the combination of row covers enclosing the tunnel during periods of extreme cold can help protect the plants from midwinter damage. Flowering and pollination management, oftentimes the number of naturally occurring pollinators is reduced within the high tunnel environment, and particularly if our goal is an early ripening crop where we're encouraging early flowering. So there can be a benefit to provide pollinators within the high tunnel. And frequently what is used is bumblebees. A bumblebee hive is placed in the high tunnel as the initial flowers open. Again, remember, as I said earlier, those first blossoms that open are the primary blossoms. They will develop into the primary fruit, and that's typically the largest fruit in the truss of blossoms and fruit. So it's important to put some time and energy into developing those initial blossoms and initial fruit. Remember that harvest will be earlier than with field planting, so be prepared from the standpoint of your marketing. And I thought it might be interesting to take a quick look at what goes on inside a bumblebee hive. I've worked with bumblebee hives over the years, and you place the hive and the bumblebees come in and out, but I always wondered about the inner workings of a bumblebee colony. So recently I had a chance to view an observation bumblebee hive, where basically a commercial hive was opened up and we were allowed to look inside of it. So let's take a quick look at a video.
She's coming out a little bit, and I didn't know why she's messing with the larvae.
If you look closely, you can see the queen there at the very center.
Oh, there's a cup there. She's getting maybe to oviposit in that cup. See, she's coming up.
Oh, yeah.
She's got to get things just right. She's like a chicken. Got to get in that nest and turn around. That's what she's doing. Look at that. And then I bet when that egg goes in, then the workers start to build the cell. See, she's ovipositing in the cell just below her right now. Can you see the egg? Or is there even a cell there? That's good, because I didn't see a good cell.
Strawberries, day-neutral strawberries have certainly been grown for season-long production here in the Midwest, and they can be grown as a fall crop in the high tunnel. Keep in mind the issue related to high temperatures, and temperature control becomes important. If you wish to grow a late summer or fall crop, it'd be good practice to provide some shade cloth over the high tunnel. The other issue has to do, as we'll see here in a moment, with spotted wing Drosophila management. And strawberries are very attractive to spotted wing Drosophila, and several farmers have lost most of their crop because of issues with spotted wing Drosophila management late in the season on strawberries. So before embarking upon a late season production cycle with strawberries, very important to think about management of spotted wing Drosophila. Well, I'm glad that day neutral production was brought up, kind of touched on some of the basics, but yes, day neutrals could be used for a type of production that would lead to summer and fall berries. Again, as I mentioned earlier, a couple of caveats. One is temperature management. The other would be management of spotted wing Drosophila. Greenhouse production during the winter. There's certainly the potential to grow both June-bearing strawberries and day-neutral strawberries during the winter in a climate-controlled greenhouse. Now, keep in mind that you'll be competing directly with strawberries coming from warm production areas such as California, Mexico, and Florida. And it would be very important to think about the economics of doing this, but it certainly can be done. And if you have a premium market for locally grown strawberries during the winter, this might be something to consider. Strawberries are also a crop where there's the potential to grow them under hydroponics. They would be established typically in a thin film type system where they're grown in gutters. I have seen strawberries also grown in raft systems, but more typically they're grown in a thin film type system. And if anyone would like more information on hydroponic strawberry production, please reach out and I can share more resources. Now let's talk a little bit about strawberry integrated pest management. And remember that integrated pest management is not just what do I spray to manage problems. It's an integrated approach looking at all of this management strategies that are available to farmers to manage disease and insect problems. In many cases, there are strawberries that have genetic resistance to diseases such as red steel or verticillium. And it would certainly be in the interests of IPM to plant those cultivars here in the Midwest. Also important to consider the adaptation of strawberries and plant those strawberries that are hardy. Strawberries that have suffered winter damage are vulnerable to disease issues. So on the disease side, botrytis gray mold, anthracnose, leather rot, red steel, verticillium wilt, and leaf spots are seen with some regularity here in the Midwest. We'll see what these look like, or what several of these look like here in a moment. Among insect issues, plant bugs, mites, spotted-winged Drosophila, Japanese beetle, and stink bugs are the primary insects of interest. Now, rather than spend a lot of time talking about the tactics that are available to manage these pests, I'm going to refer you to the Midwest Fruit Pest Management Guide. This is a guide that is produced by specialists across the Midwest in consultation with farmers. The guide is produced every 2 years. The print form, we're looking forward to a revision in 2021. The online form is revised at intervals as pesticide labels change. Take a look at the guide. It has lots of information. It's not just a listing of sprays. It's a listing of management strategies. And encourage everyone to take a look at this particular guide from the standpoint of managing strawberry pests. Just some pictures to show you some common strawberry issues. In the center is botrytis gray mold, a very common fruit rot on strawberries. Integrated pest management strategies for botrytis gray mold include planting on raised beds, include not over-fertilizing with nitrogen in the spring. This disease is always more of a problem if the berries are buried within a dense canopy. So don't over-fertilize your strawberries. Prompt removal of any rotted fruit is important. In fact, organic farmers typically will encourage pickers to take 2 containers, 1 container for sound fruit and 1 container for botrytis gray mold. And it's worth paying people to pick rotted strawberries to get them out of the field as part of an overall management plan for botrytis. Strawberry leaf spot in the upper picture there, this disease can be managed by removing the foliage during renovation. As I mentioned, leaf removal can be part of the renovation practice, and by removing these leaves infected with leaf spots, we can actually break the leaf cycle or break the disease cycle for leaf diseases. Verticillium wilt, the lower picture, plant-resistant cultivars, and plant in ground that has not had strawberries, solanaceous crops, or brambles growing on it for the past 4 to 5 years. Here are some common insect pests. The upper right picture is tarnished plant bug. Feeding by tarnished plant bugs can lead to distorted berries. The lower picture in the center is the Japanese beetle. And Japanese beetle is not much of an issue on annual systems because by the time the beetles emerge and become damaging, the plantings have been discarded. But it can certainly impact perennial matted row plantings. Brown marmorated stink bugs and other stink bugs can cause problems on berries as far as distorted berries as well. Spotted-winged Drosophila there in the upper center picture. Now, management strategy, spotted-winged Drosophila, again, is primarily an issue on day-neutral plantings that are in place for summer and fall production. Again, the spring crop of strawberries, whether it's Perennial Matted Row or Annual Plasticulture, frequently is harvested before spotted-winged Drosophila numbers build. Japanese beetle can be managed by trapping. Stink bugs and tarnished plant bugs are more of a challenge, and typically they are managed through the use of labeled insecticides. There are other strawberry pests that can become a problem. Nematodes. Nematodes are tiny worms, sometimes microscopic worms, that live in the soil that feed on strawberry roots and can result in lower vigor plants or sometimes even plant death. It's a good practice to do a nematode test on a site before planting, and if there are high levels of damaging nematodes, it may be best to avoid that site from the standpoint of strawberry production. Slugs and snails can be a problem, and from the standpoint of managing slugs and snails, they can be baited. They can also be trapped within various types of traps with organic baits. Mice and other rodents can be an issue. Mice and other rodents frequently are managed by trapping as well, or by maintaining habitat for their predators. Birds, if birds become an issue, the plantings can be protected through the use of netting. Deer can be a serious issue on strawberries. And in fact, I remember a situation several years ago where 3 acres of strawberries were lost over one weekend by deer coming in and grabbing the plants, jerking them out of the ground, and then eating them. Deer management is best done with electrified or barrier fences. And then viruses can be a strawberry problem as well. Always important to source planting stock from nurseries that have a program in place to test their plants for virus problems. Let's talk about strawberry harvest. So harvest begins about 30 days after flowering starts. So if your first flowers open in the first week in April, your first harvest will typically be in the first week of May. Again, remember in the high tunnel, we can have flowering as early as late March, which can, of course, give us a crop sometime as early as early March. We can give us a crop as early as early April. Harvest berries at least 3 times per week, and in warm seasons, they may need to be harvested more frequently than that. Berries should be picked as ripe as possible. Berries do not improve in quality after harvest. So we want to pick berries that are fully ripe. Now, how do we know if a berry is fully ripe? The berries should be completely colored. There should be no white tip or lighter colored tip on the fruit. And the berries, though, should be harvested before they begin to soften. So again, this is why harvest needs to be quite regular during the season. The berry should be picked with a stem attached for a longest shelf life. If you pick the berry and the stem, and especially if the calyx are removed, this can greatly shorten the shelf life of strawberries. And particularly if these berries are going to be marketed off the farm, it's important to leave the stems attached for the longest shelf life. Berries should be picked into shallow marketing containers. Typically, you don't want a depth of more than 4 to 5 berries in the harvest container. Anything deeper than that will lead to crushed fruit in the bottom. And berries should be harvested early in the day, before 10 o'clock if at all possible. At this point, the berries are still fully turgid and they'll be of maximum size. If you delay harvest until later in the day, the berries will have lost moisture to desiccation, and you can lose up to 10% of fruit volume by harvesting late in the day versus harvesting early in the day. As soon as the fruit is harvested, it should be cooled down immediately to maximize shelf life. And if the berries are going to be held for any length of time, they should be stored at about 35 degrees Fahrenheit. A strawberry, if it's harvested at the proper time when it's fully ripe and handled carefully, cooled immediately, and then put into storage as soon as possible, has about a 5-day shelf life. You need 6 to 10 pickers per acre to harvest strawberries at the peak of harvest for a given cultivar. Now remember that the primary fruit ripen first. Typically, the first harvest on strawberries will be about 15 to 20% of the harvest off that plant. The majority of harvest will come in the second week of ripening. This is when you need that 6 to 10 pickers per acre. For pick your own harvest, frequently the farmer will provide a 4-quart basket or a 4-quart busket. That lower picture is a busket. It's a ventilated plastic pail, again, that is wider than it is deep. Cardboard flats can also be used for harvesting strawberries. Now for pre-picked berries, they're frequently harvested into plastic clamshells that are a quart in size. In some cases, berries are harvested into smaller containers, but growers report that it's difficult to provide an attractive pack in anything less than a quart-sized container. But a quart, quart and a half, or 2-quart containers are frequently used, and plastic clamshells are widely used as well. Some growers are harvesting into pulp containers, as we see in the upper picture, and then the berries can be left open or they can be covered with a piece of plastic film that's secured with a rubber band. Strawberries are a valuable crop. The fresh market price is somewhere between $3 to $4 per pound for pick your own and $5 per pound for pre-picked berries. They're well suited for pick your own marketing. They're also excellent berries from the standpoint of on-farm sales through farm stands. They can be taken off farm and sold through farmers markets or as part of a CSA share. Locally grown strawberries have a role from the standpoint of wholesale markets. And increasingly, we're seeing strawberry farmers who are marketing to schools or to institutional markets or even to wholesale brokers. And as we mentioned at the beginning of the class, there are value-added opportunities for strawberries. Traditional products such as jellies, jams, or sauces, or strawberries can be incorporated into more creative value-added products as well. There's an excellent strawberry enterprise budget at this website. I'm not going to go into details with it, but I encourage you to consider checking this out, particularly if you are a new strawberry grower. There are enterprise budgets for both field-grown strawberries and high tunnel strawberries at this site through the University of Missouri. Now, some general thoughts on planning a strawberry enterprise. Definitely, it's important to plan. If you're new to strawberries, you need to learn about strawberry production, and you need to understand what it takes for success. Again, strawberries are a management-intensive, labor-intensive, input-intensive crop. The potential is there for profit, but it's important that you understand what it takes to produce a successful crop. Remember that there's risk, particularly for annual plasticulture, and you want to consider all of the risk management strategies that are at your disposal. Again, the use of things such as floating row covers, considerations such as growing under protected culture. Remember that the price and the return varies with location and market, and know what your potential market is. Think about your yields and be prepared to market a high yielding planting. Okay, but again, recognize that there can be stresses, risks that can lower productivity in a strawberry planting. Annual plasticulture does have the potential for higher yield than perennial matted row, but remember that the investment is also much larger with annual plasticulture. Remember that the actual cost to establish and maintain a strawberry planting varies with location, with the type of system you choose, and with your management practices. Your main variable costs are planting material, about 25% of inputs. Your labor, that's about another 25% of inputs. The main fixed costs are your freeze and frost control. The floating row covers are actually a fixed cost because you use them for several years, and that fencing we mentioned against deer. Some good resources. The Midwest Fruit Spray Guide that I mentioned earlier, but also the Midwest Small Fruit Pest Management Handbook, which is a companion to the spray guide. The Midwest Strawberry Production Guide is available as a free downloadable PDF, so check that out. There's also organic fruit production guides, including organic strawberry production guides, available from Cornell University and from the organization ATRA. So check out these two websites. And then the University of Missouri has produced a strawberry cultivar guide, which is publication G6135. So we've covered a lot of material relative to strawberry production. And again, I'll thank everyone for attending. And if you have any questions that we didn't cover tonight, you'd like more information about strawberry production, please feel free to reach out. I'm in the Webster County University of Missouri Extension office, and you can give them a call or drop me an email, and I'll be happy to visit with you about strawberries.